Let's understand an ellipse. To understand an ellipse, we will consider two things. We begin by considering a straight line, which will be referred to as the directrix. Then we're going to consider a line that is perpendicular to the directrix. On this line, we're going to consider a point, and we're going to name this point as F, which will be referred to as the focus. Next, on this plane containing the directrix and the focus, we're going to consider a point P with the coordinates x, y. This point P is referred to as the locus. Now, let's join point P and point F. And from point P, we're going to drop a perpendicular on the directrix line, meeting it at point M. Now, the way the point P is lying on this plane is very important. If the position of point P is such that it meets the criterion that the length of point P, length of the line segment joining point P and point F, that means PF, and we divide it by this perpendicular distance PM, then this ratio must be always less than 1. And if this particular criterion is met, and it should be greater than 0, if this particular criterion is met, then the path traced by the locus or path traced by the point P is going to be an ellipse. So we can define an ellipse as the locus of a point, so our point will be point P, that moves on the plane with the ratio of its distance from a fixed point. A fixed point is referred to as the focus, to the distance from a fixed straight line, and the straight line is going to be the directrix. We are talking about the length PM, always remains constant, and this constant value is going to be less than 1. Then what we get is an ellipse. Let's try to understand this with the help of a problem. So here we need to find out the equation of an ellipse whose focus is at 1, 0, and the equation of the directrix is given to us, and it's also given here that the eccentricity of the ellipse equals to 1 over square root of 2. So let's begin. We'll try to understand the problem graphically here. So here we begin by considering a straight line which is going to be referred to as the directrix. Its equation is x plus y plus 1 equals to 0. Next, we're going to consider a line that's perpendicular to the directrix line. And on this line, we're going to consider a point which is going to be the focus. So focus having the coordinates 1, 0. Now to find out the equation of the ellipse, we're going to consider a point P on the plane containing the directrix line and the focus. Let's give it some coordinates. Let the coordinates of point P be x, y. Here point P is going to be the locus of the ellipse. Now we will join point P and point F. And from point P, we're going to drop a perpendicular on the directrix line such that it meets the directrix line at M. Now, the position of point P is very important. Point P has been chosen in a very specific manner such that if we take the ratio of the distance PF and divide it by the perpendicular distance PM, this will be equals to the eccentricity E. So here eccentricity is 1 over square root of 2, and we have already defined that the ratio must be less than 1, and of 1 over square root of 2, it has a value less than 1. So that's going to be this constant ratio, that's going to be the eccentricity of the ellipse. So this value is given as 1 over square root of 2. We can now solve from here. So PM will be equals to square root of 2 times PF. Okay. Let's find out PM. So PM is going to be the perpendicular distance of point P from the directrix line. There's a specific formula for this. So let's say we have a point P with the coordinates x1, y1, and then we have a straight line with equation ax plus by plus c equals to 0. So we have the equation of the straight line in its general form. Then from point P, we drop a perpendicular on the straight line, meeting it at M. So that means the PM was going to be the perpendicular distance of point P from the straight line. The perpendicular distance can be obtained by using the formula. So we take the absolute value. Within the absolute value, we have to take a ratio. In the numerator, we'll take the coefficient of x of the straight line and multiply it with the x coordinate of point P to get ax1. Add it to b times y1. So b will be the coefficient of y and y1 is the y coordinate of point P and add it to the constant term C divided by the square root of a squared plus b squared. So a squared plus b squared corresponds to the sum of the squares of the coefficient of x and y. That means in our case, we will find out PM by taking the absolute value. So here we have to take the ratio. We'll start with the numerator part. So the coefficient of x of the directrix line, that's 1. 1 will get multiplied to the x coordinate of point P to give us 1 times x. Added to coefficient of y of the directrix line, that's 1. 1 gets multiplied to the y coordinate of point P. And then we take the sum of the constant term, that's 1. And we're going to divide it by the square root of sum of the squares of a and b. So we have 1 squared plus 1 squared. This will be equals to the square root of 2 times PF. So here PF is the distance between point P and point F. So here we can use the distance formula. We'll take the square root. Underneath the square root, we need is the difference of the x coordinate and then square this value. So difference of the x coordinate will be x minus 1 added to the difference of the y coordinate. So that's y minus 0 and square this value as well. To further simplify, we'll square both sides. So we get x plus y plus 1 whole squared divided by, so in the denominator we have square root of 2. Squaring it gives us simply 2. This will be equals to, so here we have square root of 2. Squaring it gives us 2. This will be multiplied to x minus 1 whole squared plus y squared. So let's expand x minus 1 whole squared to get x squared minus 2x plus 1 plus y squared. Now we will simplify from here. So we have x plus y plus 1 whole squared. When we expand it, we get x squared plus y squared plus 1 added to 2 times xy plus 2 times y plus 2 times x. This will be equals to 2 multiplied to 2, so that's 4. So we have 4 times x squared, that gives us 4x squared minus 8x plus 4 plus 4y squared. Now we're going to combine the terms, the like terms. So 4x squared minus x squared gives us 3x squared. This is done. Next we have 4y squared minus y squared, that gives us positive 3y squared. Then we'll have negative 2xy. Then we have negative 8x. We have negative 2y. We also have a 2x here. This is going to make it positive, negative 10x. This will be negative 10x. Then we have the constant terms, 4 minus 1, that's going to be positive 3 equals to 0. Thus, we have successfully obtained the equation of the ellipse. So that's given by 3x squared plus 3y squared minus 2xy minus 10x minus 2y plus 3 equals to 0. So this is the required equation of the ellipse. Whose equation of the directrix, coordinates of the focus, and the eccentricity were given. So what we'll do here, we will sketch the graph of the ellipse on a standard graphing calculator, and let's have a look at it. So here we have the graph of the ellipse. The blue line is going to represent the directrix of the ellipse. The red line is going to be the axis of the ellipse. Here we have the point A. Point A is going to be the coordinate of the focus, which is given as 1, 0.